Okay, good morning, everyone. Welcome to this first edition of the Africa-Europe Cluster of Research Excellence Masterclass series on data science and the modeling of football. Our first speaker is Professor David Sumpter from the University of Uppsala. And I will keep this introduction short because of the echo. David has been working on machine learning and artificial intelligence, on fish schools and colonies, social psychology, and many other things. And he's published many papers and impressively many books. Yeah, one of them was just published, I think, a month or two ago. Yeah, which is called The 4 Ways of Thinking. Yeah, which promises to be very interesting. And next year we will invite him here to do a proper book launch. Yeah. So David, because of the echo, I will keep your introduction short. Everybody, I think, is very excited to be here this morning. I think we have more than 100 participants online.
Okay.
And
wow.
I'm not sure how many in person,
Okay.
but we will do the audit later. Yeah. Okay, David, please, over
That's
to you.
very good. Thank you very much, Francesco. What I want to actually start with is just say a little bit about these masterclasses, because I'm giving the first of these masterclasses, but it was also my initiative to set them up in the first place. And if I share my screen here, first, I want to actually ask you all, can everybody, a few people have typed in where they're from. Could everybody type in where they're from so we can find out? And also, if you're a group, you can say that you're a group from somewhere. So if everybody can type into the messages where they're from, it would be nice to see that to start off with. Good. So while I'm doing that, what I want to just show you is something about what the masterclass is all about. Away that. There we go. So you should be able to see this now. So I think if you haven't already found this webpage, then you should have a look at the webpage, and that means that you can register for future masterclasses as well. I'm just trying to get the Zoom there so I can put that in the chat. Well, I'll put that in the chat later. Oh no, here we go. I'll put that in the chat so you can see that. That's the web page. And it's very nice that we've reached out. So far, I can see people from Makerere, from South Africa, everywhere around the world is coming up there in the chat. And what we'll be doing is we'll be offering courses in artificial intelligence from all around Africa and Europe. And we've got a great lineup of speakers. The first one here is me. This is me talking now. Then next, in 2 weeks' time, we're going to have one on responsible AI, bias and fairness, which is a growing and important question in AI. And then later in the month, we're going to have one on high performance computing. And so each of these will offer a quick dip into these research areas and a deeper understanding of them. And they're aimed really at master's students and at PhD students, and also professional practitioners who want to learn more about these particular areas. It seems like many of you are, but you should, if you want to join a local group, here's the email addresses, and then contact that person, and they'll organize. Everyone's organized a place where you can sit and be together and work on these things together, because I think it's much better if you can work together in a group on these particular things. So that will be the idea there. Good. So have a look at that. But with no further ado, that's the advertising done. No further ado, I'll get on and start talking about what I'm going to talk about today. And what I'm going to talk about today, can everyone see the screen?
Yes.
Yes, great. Okay, so what I'm going to talk about today, and I think, I won't say that everybody loves football, but lots of people love football. And I think that I found that football is a very good way to come in to machine learning and artificial intelligence, because it's a very concrete example of how we can work and we can use models to understand the world. Now, I came into football from quite a strange route. I get lots of emails every week from people who say, oh, I'm a massive football fan and I want to start working on analytics in football and so on. And I didn't really come in that route. I mean, I was a sort of average football fan. But what I worked on, what my research was on, which Francesco mentioned, is my research was on, need to click there. Yeah, my research was on animal groups. So you've actually got up here some examples of the animals I worked on. And I worked on everything from insects through shrimps to even to human behavior. These are locusts in the Sahara Desert. There's pigeons, some more humans, even chickens. So I worked on all aspects of animal behavior and how we could build models to describe them. And what grew out of that is a set of mathematical tools in order to do that type of modeling. And after I'd worked on this for 10, 15 years, I really wanted to sort of come out and talk about this with a broader public. And the result of that was a bit strange, because I wrote to some publishing agents and they said, well, nobody's interested in animals. People are interested in football. And I ended up writing a book about football and mathematics, how we could use mathematical modeling in order to better understand football. And that was because I had one example of football. And the agent I contacted in London, he said, you know, just build on that. So I ended up writing a book all about things like game theory in football, how you can look at passing networks, so graph theory, also like spatial creation, so geometry of the game, Newtonian dynamics of shooting. So all different aspects of football that you could model with mathematics was part of the book. And that book came out a few years ago. And what's happened since then, so I really just wrote it in order to sort of illustrate how mathematics is used. I didn't really, well, at the time I thought it would be interesting if clubs took it seriously, but it turned out that people in football took it very seriously. I got invited down to Barcelona. I haven't actually met Lionel Messi, but this is as close as I've got to him. And I went to La Masia, which is the training institute there in Barcelona, and met all the staff there. I'm going to come back to some of them later because I ended up working with them. I visited Ajax and worked with a data scientist there. And this is me. I don't know if you recognize this character here. This is Gary Neville. So this is me doing a TV thing together with Gary Neville, which was quite a lot of fun. I was talking about the benefits of statistics and he was arguing for more common sense methods and things like that. So that was lots of fun. And most of all, I got to work with Hammarby Football Club. This is me at the ground monitoring some of the game. This is me together with the players, and actually worked closely together with the players. And so writing this book gave me an opportunity to work very closely with different aspects of football. And it's been a very exciting journey. And over time, more and more football clubs are using mathematical methods in order to understand the game. Most Premier League clubs are using some form of mathematics now, and clubs all over the world are starting to use mathematics. So it's a massively growing area, and there are opportunities for people who would like to work in it. Okay, so let me do this. That's a kind of little background from me. Let me do this. Let me start with goals, because we know that the most exciting thing in football is the goals. Everybody's interested in the goals. Now, I have a question for you, and you can answer in the chat. Which of these... Oh, I might have to... Okay, I'll show you. I'll go back a second. I'll come back to the goals because I don't know how to switch off the sound and still have my sound on. So, oh, maybe I can. Yeah, maybe I can. Well, anyway, I'm going to show them with the sound. I'm going to show you two goals, and you have to tell me if you think the top goal is the best goal or the bottom goal is the best goal. try not to pay too much attention to which team you are, but maybe you are a supporter of one team. But if you think the top goal is the best one, write top. If you think the bottom one is the best goal, write bottom. Let's do this then. Okay, very good. There's lots of you think the top goal is the best one. There's someone's written there, Henrik's written there, bottom got in a better position. Oh, now the bottom's coming up, so that's good. It's about 50-50 who thinks which goal is best. What I want to emphasize here, I mean, of course, best maybe isn't the right word here, but what I want to emphasize here is what Henrik wrote in the chat is the position of the goal. So this goal is scored from a long way out, while this goal, when Mané runs forward, is scored from very near to the goal. And what we say in football statistics is that the goal by Mané is a better goal in the sense that there's a higher chance of him scoring that goal. This goal was really a little bit down to a goalkeeper mistake. And he managed to score this goal from long distance, but normally he wouldn't manage to score this goal from long distance. And so how do we know that? Well, what we know, what we can do, and this is something I did quite a few years ago now. This is from a Barcelona series when Suarez, Neymar, and Messi were all playing together. We can look to see where the goals are scored. So the black rings here are where the goals are scored. And you see, and the colored dots are all the shots. And the coloring is basically the likelihood of it being scored. I'll come back to exactly what I mean by that in a minute. But the black is the quality of the shots. Sorry, the black is the goals, and the color is the quality of the different shots. And you see that Suarez scores all of his goals in the box. And not only are they all in their box, they're in a kind of circle around the box. They're all in this area here. The same with Neymar. He is on the left, but he scores all of his goals within this circle. And even Messi scores most of his goals within this circle. There is a couple of goals that are outside there, but in general, Messi scores all of the goals within the circle. And this is more like, and of course you can see these red dots, these ones here, they're more like Mané's goal than they're like Gareth Bale's goal. We can also look, here is Gareth Bale in earlier season of football. And what we have is we have now the Ronaldo team, Real Madrid, which were pretty much were the Ronaldo team at that time, I suppose. But and you see Ronaldo, his shots are all spread out from outside the box. And when you look on YouTube and you look at Ronaldo's greatest goals, you'll probably see these two goals revealed. What you won't see is the 60 misses that he made or the 60 save shots that he made from distance. And so we sometimes get a misleading impression that Ronaldo can score from distance. In fact, he only scores at a rate 1 in 30, which is about typical for a professional football player from scoring from distance. He gets most of his goals, like Messi, from in and around the box. Benzema is, of course, a specialist at this, really tight area in front of the goal, finds very good shooting positions and scores. Gareth Bale did score a little bit. He had 2 goals from outside the box here, and at a little bit a higher rate than Ronaldo, so he might be slightly better at it. So that's the general rule, that the nearer you are to the goal and the better sight you have of goal, the better your chance of scoring. So that's some data. Now, the next thing we do when we're interested in modeling football is we formulate a model. So this is a model of Bale's shot. And the what I think is very important when we build models, I'm more of a mathematical modeling person than a machine learning person. What I think is very important is we have some parameter which describes reality. And the parameter I've chosen to describe football, and this comes from my own experience. So I haven't played football at any high level myself, but I've spent a lot of time training my son's team and so on. But a very important experience I've had from playing and training football is that the more of the goal you can see, the better the chance you can score. And that's what's shown in this plot here. So here are the goalposts, and up here, I'm going to show it. Up here is the position of the shot. And what I measure is the angle between the two goalposts. I'm going to call that the goal angle, theta. And so the more of the face of the goal I can see, the better chance of scoring a goal, I'm hypothesizing. And so I have this parameter theta. Theta we can also call, sometimes in machine learning, we call theta the feature. So it's the input variable or the feature of our model. Whether it's a goal or not is a 1, 0 output variable. And then we also have Manet's shot. So now the angle is much bigger. And so we have something which captures the, it's not the distance actually, because we don't have the distance. It's how much of the goal you can see determines the probability of scoring. One interesting property of the angle model is you can have 2 points that have the same angle. And that's why I like it so much, because this point out here is closer to the goal, but it's certainly harder to score from here than it is to score from the penalty spot. And you can find that this has the same angle as a long distance shot. So the parameter, why it's a good choice of parameter, is it captures more than one aspect of the game. I'm not going to go through the trigonometry here, but you can do a little bit of trigonometry of this. You've basically got, here's the goal, here's the angle, and so on. And then you can, and the goal is 7.32, is that right? 7.32 meters wide. And the XY coordinate is the XY coordinate of the shot, where Y is the distance from the center line, X is the distance from the goal. And you can derive the following equation for theta, that tan theta should have this particular value. And then what we're going to do, as you know, this is a masterclass, so you're going to do this yourself later, but you can do logistic regression on this goal angle. So here's the shot angle, the goal angle in degrees, and this is a plot of data from that, from different shots. So we've taken all the shots in the Premier League and we've calculated the goal angle, and these dots are the average. They're kind of histogram binned, so they give the average. And then we fitted this line through these shots. So you're going to learn how to fit that line in the masterclass later. That's what we're going to do as our exercise later. But this allows you to draw circles around the goal. So if you remember back to this point here, where two angles were the same, well, this angle theta defines a circle around the goal like this. It should be up here and round here. It defines a circle around the goal, which all has the same theta. And then what we can do is we can then draw lines once we've fitted the model, where we can draw a 7% line, a 15% line, a 30% line. You could also draw a 3% line, which would be out here, a 1% line, which would be way out there, which tells us the probability of scoring. Now, it's not quite as simple as that. We often use another feature. We've taken another feature called distance. Yeah, we look at the distance to the goal, and we combine those two features in order to fit the model. And that's what you're going to have a look at later. And we find that we can get it, we get a sort of squashed shape, a squashed circle, which means that you actually have a little bit better chance of scoring out here, but you still have a very low chance of scoring when you're a long way out there. Good. So that, and what I've described here, maybe you can tell me, has anybody in the chat, has anybody heard of expected goals? Do you know what expected goals are at all? So expected goals is quite big in many of the football apps. And expected goals are, yeah, there's a few yeses in there. That's very good. So the expected goals is basically this model. What I've shown you is the first mathematical steps towards building an expected goals model. Now, I run a company 12 where I think that website's out of date, I'm afraid. But what we do is we have an expected goals model. And for every shot that's played in football, we can assign a value to it. You can actually download, if you go into 12.football app, you can download an app which gives these expected goals model, but they're built into quite a few different things. And so what we've now built is a model for evaluating shots. We can say that a shot here, a shot on this line, shot on this line is worth 30%, a shot on this line is worth 15%, a shot on this line is worth 7%. And that can be used after a match. So if a team have had very good chances, but maybe they haven't scored as many goals, you can see that they have a high total expected goals for that particular match. What's important here is that we have a principle that's both mathematical and statistically grounded, grounded in coaching, and everyone understands. So everyone understands. What I mean by everyone understands the more you can see of the goal, the better the chance you have of scoring. When you think about coaching, that's exactly the type of thing that the coaches say to the players. Find a good shooting angle is a very important thing. And then we have a mathematical model which describes it, and we also have a statistical fitting which describes how it all works and fits together. And that is always what you want to do when you build a mathematical model of football. Now, what I'm going to do now is I'm going to jump onto a little bit more advanced material, and then we're going to come back to looking at the expected goals model ourselves and building our own expected goals model. And that's what you're going to do in groups. So so where we're going to move on to more advanced material. So this is possession chains. So we've got a model now for, actually, what I'll do is I'll just pause for 2 or 3 minutes. If you've got any questions I can answer about expected goals, please put them in the chat, and then I'll move on to the next material. No questions? Yeah, that's a good question. It's come in from a couple of places there. Does it take into account defender positions? And the answer to that is no, the current model doesn't, but we're going to look in, I'll show you on the web page where we do take into defender positions account. So this is basically because of the data collection we have. So we have data which just collects the positions of the team. So yeah, it doesn't take into account defender positions. Yeah, there's a good question about the force required for the shot come into play, in the sense it being closer is easier. Yeah, that's exactly right. So there is the distance parameter comes into play there. And one very interesting suggestion some people have had is that maybe when it's more than 25, also, yeah, the other thing that comes into play is the reaction time of the goalkeeper. So it's basically impossible to react to a shot that's less than about 15 meters. So that's another thing that comes into play. So there's various things that come into play like that, which are sort of picked up by the distance and the angle parameter. We'll come back to things like ball possession correlated with XG. That's very good. Does XG change throughout the XG can change a little bit throughout the game, in that there's often a bit of a higher chance of scoring later in the game, especially when a team is behind. So it can change a little bit. But things like Eric's asking is fatigue. Normally, these models don't do that. What we find is that goals tend to be quite well. Could you open the door? Sorry, sorry, just let someone coming in. Yeah, so so they don't. Fatigue doesn't tend to be factored into these things, but you can have that. There's some great curves here about what. No, I think right. What you can do, and this is, I suppose, the beauty of mathematical model, is you can build up in layers all of those things. So a typical model won't take into account fatigue, if it's a curved shot, the positions of the defenders and so on. But step by step, if you're interested in those factors, you can build them into your model and improve your expected goals model. And I often say that there's no single expected goals model. There's actually different expected goals models depending on particular needs that you have. The two, I mean, I can't say the five highest features, but the two most important features are the ones I've told you. Once you have those two features in, the shot angle and the distance to goal, then you're on a good way to having the model. It's difficult to make too many improvements over that. Probably it's the number of defenders in the way, which is the third most impressive thing. Great questions. Well, actually, I'll try these last two here. Is expected goals correlated with the level of the team and the league? Expected goals is pretty independent of the team and the league, but that's because they're playing in their own league. So it's easy to, so when you're playing in a lower ranked league, the expected goals models tend to be around about the same. And there's a question here about goalkeepers. Well, you can actually use these models to evaluate goalkeepers. Do goalkeepers manage to save particular situations, and how well do they handle different situations? You can measure that with the expected goals. And limitations of the model, well, I think I've been going through there are a lot of limitations of the model. It's a first attempt to kind of get an idea of the quality of shots in football. So yeah, that's exactly right. These different factors also show the limitations of the model. Great, thanks for all those questions. Really nice to get that feedback and see that you're all following along there. So, okay, next up, I'm going to move on to possession chains. So we've got a model now of goals. And as I said, this is a little bit more advanced material. And during today, we're going to study expected goals and build our own expected goals model. That's what you're all going to do after this. But I'm going to start with, well, before that, I'm going to look at possession chains and how we could evaluate passes. Now, to give you some idea of where we're going, I want to show you the following figure. This figure shows the value of different places on the football pitch. If you look here, we've already seen that, well, when the ball is very high near to the goal, it has a very high value. So if you look carefully, there's inside here, it says 0.377 in this white square. You won't be able to read it on your screen, but the white one says 0.377. And what that means is that if you have the ball there, your probability of scoring before the opponent get the ball back is 37.7%. So we already saw the 30% ring. You're well within that ring, so your chance of scoring from there is 37.7%. Then going out, it's 18.4%. Here it's 7.5%. And then here in the middle of the pitch, the probability of you scoring is 0.5%. So the probability of you scoring before the ball goes out is 0.5%. An interesting observation, if you look a long way out here, is that it's actually 0.025. So when the goalkeeper has got the ball here, you've got a higher chance of scoring than when you've just got the ball in the middle of the field. And that's because the goalkeeper can often make a long pass up, which can lead to a counterattack. So what we now have, I showed you the expected goals model before, but what we now have is a model which we call expected threat. And that expected threat model tells you the value of anywhere on the football pitch. What's the value of having the ball at that particular place? And where did this come from? Well, I always like to emphasize these things as a mathematician, that this came from, the ideas here started with something called Markov chain theory. So Markov chain theory is a mathematical theory of, well, how you evaluate the probability of something happening. So a classic example of a Markov chain is you might look at the weather. It's been raining today. What's the probability it's going to rain tomorrow? It's been raining today. What's the probability it being sunny tomorrow? And you can use that. You can use the frequencies to work out the long-term probability of rainy and sunny days. And what Sarah Rudd did, who was one of the pioneers of football analytics, what she did is she broke the pitch down. In the figure I had, I broke the pitch down into lots and lots of little squares. She broke the pitch down into 7 important zones, 0 up to 6. So when you've got the ball out of the final third, we know that that's got quite a low value. You can have the ball down at the corner flags, that's 4 and 6. You can have the ball in the middle, that's 2. You can have the ball out on the wings, 1 and 3, or you can have the ball at 5. And then she built a model looking at the transitions between those areas. And so if the ball goes into the goal, then it's in the goal, right? The possession's finished. If the ball goes out of play, it's out of play and the possession's finished. So we have a 1 in these things. But for the other ones, if the ball is in area S1, 0.5 is the probability on the next second of play that it's still in area S1. This is the area, this is the probability it goes to areas S2, S3, and so on, all the way up to Sn. And we can write down a matrix which shows the transition probabilities between the different areas of the pitch. And this allows us to model a game of football in terms of a kind of random process where the ball bumps around in these different areas of the pitch. To give another example, another way of doing it, this is how I wrote about it in Soccermatics. M might be in the midfield, W is the wing, L is lost, B is box, and G is goal. And these transition probabilities are the probabilities you move the ball to the different sites. So we can work out those probabilities. Now, this method has, after a very popular blog post by Karan Singh, which you can have a look at there. If you look at, it's Karan Singh wrote this blog post. What he did is he formulated it and provided code and a method for calculating these types of transitions. So what he did is he collected up the data, he broke down the pitch into these squares, and then for this particular square here, he looked at the probability that a team shoots from there. He found that it's 30%, and the probability that they move the ball. And if they move the ball, this heat map shows the probability where they move the ball to. So if they move the ball, they're most likely to just keep it in the same place, but they might move it to here with a high probability, and a lower probability they move it out here. And so this allows us to look at the game in exactly the same way here, but on a more detailed level. So we look at the probability you move from one place to another, and you do exactly the same here. Here's the probability you move from one place to another. And how did we formulate this mathematically? Well, what we want to do is we want to solve the problem of looking at the long-term probability that if you have the ball here, it's a goal. Now, 30% of the time you'll shoot and you'll score 2% of the time. So that gives 30% times 2% chance of scoring, which is 0.6% chance of scoring. But if you move the ball, you might also score. You might keep possession and move it to another place. And so the equation that does this, I'll try and explain term by term how this works. The equation that does this term by term is you want to work out the value. That's what we're going to call the expected threat, the value of a particular point. And we had two things. We said, well, I said there was a 30% chance that a player would shoot. That's the shoot probability here. XY is the coordinates. So think of this as an XY grid. This is X in this direction, Y in this direction. So SXY is the probability of shooting from position XY, which for the XY we looked at was 30%. Then we have the probability of a goal. Well, we actually already know, because we have an expected goals model, so we already know the probability of scoring from particular points, and that's the expected goal, GXY. Then always in probability, when it's something else can happen, when it's or, then it's a plus here. So this is now all the terms for shooting. So in order to score, you have to shoot and you have to score. So it's a multiply, shoot times goal gives you the probability of scoring. Or if you don't shoot, then you move the ball, and that's the move probability. So that was 70% in the example on the previous slide. Then this is a little bit of a complicated part, but I'll try and break down what we're trying to do here. Now, remember, so you see these numbers 16 and 12. Now, remember that we broke down this grid into a 16 by 12 grid of the pitch. So the pitch is broken down into a 16 by 12, so 16 along the x-axis and 12 along the y-axis. And that's what these things are doing. And we sum over all of the places, all of those positions that the ball can go to. So 1 to 16 for the x direction, 1 to 12 for the y direction. And then we have a transition map, which tells us how do we get from xy to zw. And that transition map is this green thing here. So there's a high probability of going from this xy position to this zw position, or this one. There's a lower probability of going out to that. And so each of the values in this green matrix makes up the values in what we call the transition probability, the transition between the thing. And then once you've moved the ball, so we've decided to move the ball. This was the probability that the ball goes to a certain place. Well, then you've got a new value, which tells you where your value is of having the ball at ZW. We've moved the ball from XY to ZW. So now we have a new value at ZW. And we can solve this equation by iterating it. And what we do is we start by setting Vxy for all of the points equal to 0. So we say, well, we've got the ball here, but we're going to say that we start with just setting this to 0. Then we say, well, okay, what happens if we take a shot from there? And then if we take a shot from a particular point, we get this SXY times GXY, that we get this value, and we can use the expected goal model to look at that. We get a curve that looks like that. So that gives us the Vxy for shooting directly. So here it's very high, of course, and further out it's very low, just like we saw in the expected goals model. Then next we iterate one more time, and we have the pass probability. So this is now iterating. We've got two actions. We've got the shot directly, or we've got the pass. And now you can see that the probability of scoring is sort of coming further and further out. So if you've got the ball here, you can score from further out. So each iteration takes us further and further out. And then we iterate this over time. So this is after one move. That was the one I showed you with the shot move, the shot. After two moves, it's spread out like this. After three moves, it's spread out like that. And finally, after 5 moves, we've got the whole pitch. It's a slightly different model than one I showed you at the start, but this gives us the final expected threat for all of these things. So that, and okay, I've said this is the method for calculating this thing. I'm going to show you some of the code for doing this later. And it also allows you to evaluate players. So you can find for any particular zone, and if you go onto Karan Singh's webpage, he illustrates this in detail. But if you go to any particular zone, you can find the top contributors from those zones. And maybe anyone who watches the Premier League won't be surprised to see that Kevin De Bruyne, this was a few seasons ago, and now I suppose Kevin De Bruyne's injured, but he's very high up there in contributing to expected threat. And he is one of the players who's best at this. It's quite an interesting story that Kevin De Bruyne, when he was negotiating his new salary with Manchester City, he employed some data scientists to analyze his game and to show that he was one of the best players in the game. I'm forgetting about you guys. I'm just talking in there. I've got a group of people sitting here and I'm talking into the screen. I just... Yeah, so yeah, Kevin De Bruyne is really he's one of the greatest players in terms of this expected threat measurements. Good. I'm going to just quickly, I want to get onto the problem that we're going to look at. So I want you guys all to work together or to do some work quite soon. So I'm going to leave it there. But I do want to talk a little bit on just 2 or 3 minutes about other ways of doing this. So the expected threat model that we've calculated here isn't the unique way of doing it. We often use instead a method based on possession chains. So instead of thinking of the game as like hopping around different squares, you actually evaluate the quality of chains leading to a goal. And so we can break any shot down into the possession chain before the shot. And there's various ways we can measure that, but I just want to explain a little bit about the machine learning method, which we call action-based expected threat, which allows us to evaluate these types of chains. So what we do in this method is, this is particularly relevant to the people sitting in Uppsala with me just now who are going to be working on a project with this. What we can do is we can look at lots and lots of chains of possession. So this is chain A, chain B, chain C. Chain C starts with a throw-in, there's a pass, there's a throw-in, there's a run with the ball, a pass, and so on. And then the ball goes out for a corner, maybe. This one, A goes in. Oh, sorry, I've got C, and C continues out this way. A continues around this way. And so what you can do is you can think of every attack the opposition have as consisting of these types of chains of possession. This one, B, I've put it in bold because it ends up being a goal. So it ends up scoring a goal. And that allows us to formulate a machine learning problem of the following type. There's also various ways of setting it up, but one machine learning problem we can set up is like this. We say that what's the probability of a shot given the start and end coordinates of a pass? So what I've done is I've taken all of the coordinates, the start and end coordinates of the chain, and I've looked at x1, y1, the passes here. And I've found that what I can do is I can predict at the end of it, these are my input variables here. If we think of it as a machine learning problem, these are my input variables. Shot is my output variables. And so I can write down if there was a shot at the end of it. And for all the passes in chain B, there is a shot at the end of it. So I write a 1. For all the passes in chain A, there's no shot at the end. So I write 0. And for chain C, there's no shot at the end. So I write a 0. And what I'm trying to do in the problem is predict, is there going to be a shot given this type of pass? And I'm interested in particular in these types of passes, these ones here. Or I'm interested in all passes, but I'm going to focus on that in my prediction problem. And we can also then say, well, if there is a shot, so here there's a shot, is it a goal? And that's basically the expected goal value. So if we know there's a shot and we know that there's been a sequence of these passes, does it end up being a goal? And that allows us then to calculate the expected threat or the possession-based expected threat as a product of the first machine learning problem that we've solved, the probability is a goal given a shot, and all of the x1, y1, x2, y2, multiplied by the probability of a shot given the x1, y1, x2, y2. And it gives us an overall probability that a particular pass leads to goal. And so that's illustrated a little bit here. So if you imagine there's lots of possession chains that go through here, and say that we find that 10% of them end up being a goal, then we give plus 0.1 expected threat for that pass. And when we fit that type of model, we can start to evaluate every pass in the build-up. So the thickness of these passes is how much they're worth to the build-up play. I'm going to show you, to illustrate this, I'm going to show you a little video we have which gives these values. So we also give tackles values and passes values. So a pass like that is not worth so much. The scale here is 1,000. So we made it a bit of a higher scale here to illustrate it. So he does a dribble worth 2.4%, 5.6%, and then the shot is an expected goals of 0.593. So maybe he shouldn't have missed that chance, but you can see how each pass and each goal is built up. Good. What I'm going to do now is let's just have a 5-minute break, because I've been talking nonstop for 45 minutes. We'll have a 5-minute break, and then in 5 minutes I'll come back and I will present what you guys are going to be working on for the rest of the for the next coming session with the expected goals model. Okay, so 5 minute break.
Thank you.
I sent a message to this IT guy of the building. He told me it's the speaker. I told him after 2 brain cells, it's not. Because on this thing, it's perfect. It's those things. Then he told me it's the internet connection. It can't be. I have something about it. You need your laptop. I know, okay? We can put my laptop on there because I've got 3 chargers. I think I can work on my phone. Sure. Yeah. Let me bring my laptop. I was thinking of that.
Yeah, that would be great.
And you bring the same right? You know what you said the other day? You find
We're still on the break, but I'm going to share in the chat. I'm going to share information you need. You've had instructions before about what you need to install, but I'm going to just share it in the chat now so that you can get going. So I'll share all of this thing. So if you haven't downloaded, if you haven't got an environment where you can do Python on, then this is the instructions to do that. And then also maybe this is the most important one. Is step 3 is you can download the code and the model for there. So in there. So I'm sending this to your email, Otema. And maybe I need to share it to all you guys as well. But... Okay.
Hello, David, can you hear us? No, he doesn't. and we can't hear him. And now he looks like he's frozen as well. Sorry? No, I'm also on the call there. Yeah. I can send him an email.
Disconnected.
Yeah.
Like, okay, like as you move your mouse, like show you. It's like it's a really very it is Harun KMRUI/blog/expand.
Here it comes again.
Hello, sorry, I got logged out for the meeting. How it went out the meeting, but I think it was a problem at my end. The internet didn't work, so But I'm back. Can everyone hear me? Yes, good. Okay, good. Good, right. Well, what we'll do is we'll get started now with the
I'm muted again, yeah.
Yeah. Good. Well, we'll get started. And now, as part of this masterclass, it's not just me speaking. It's important that you do this. So, but what I wanted to do is I don't want to start with something like too complicated for this first masterclass we're running. And what I want to do is sort of get us starting working in Python with an expected goals model. So the learning aims really of this is to be able to run the code for an expected goals model and understand it step by step. We're going to have a focus on understanding the basics. If you want to look at other parts of the Socomatics course, I'm going to show you where the Socomatics course is now. Please feel free to. Let me show you the Socomatics course so you know what I'm talking about. So I've developed partly as, well, mainly as part of my teaching in Uppsala, this Socomatics course. And you can go in and have a look at it here.
Yeah, everything is sound is on this side. I don't know why it's not coming through.
Your sound bottom report. I've got the transcript on it. You pick up what you say. So your microphone is on. It's just not. It's not on.
Okay. Okay, I'm back again. Can you hear me again? Yeah, well, hopefully. Yeah, I can see myself on the screen, so I know that you can see me. Okay. What I want you to point you towards is the web page where it has all of the examples that we're going to look at today. And then I'm going to also get you started with this. Hopefully, if you get started, then it won't matter if we have too many technical difficulties. So what we're going to do is we're going to run the expected goals model step by step. I've sent these instructions in the chat. Maybe I should send them again. But the most important thing is that you download this particular file. So maybe I should send that just in the chat one more time. Not you guys, if you wait before you download anything just now. So that has it also has my talk in it. So if I cut out again, you can kind of see where the instructions are and follow the instructions. So if you download that folder, then you'll do that. What I think we should do, because we're having a few technical difficulties, what I think I'd like you to do is I'd like you to look at the code that I've suggested. So I'd like you to run the code. What I'd like you to do is run the code, which is called XG. Now I've forgotten what it's called. So it's called run the code, which is called plot XG model fit. And that can either be done in Spider, if you've got a code, or it could be done in Python, in some sort of Python notebook or something like that, if you use the IPYMB file. So you can run this particular code. So put these into your working folder and run them. And then what I'd like you to do now for the next 10 minutes is just get that code running. And you can see that there's different leagues of data. So plot the different leagues of data and get some plots of them and try and see if there's any differences between the leagues. So get on and work with that for the next 10 minutes. I will be available here, and if there's any questions, just put them into the chat and I'll answer those questions in the chat. So we'll come back here. We'll say at 9:30 in order to give us a chance also to sort out any technical problems. So come back at 9:30, and before that, plot some of the data for the different leagues. Okay, we'll be back then.
Yeah, his 9:30 is our 10:30.
Yes, 10:30, exactly, 10:30.
Yeah.
So the links, so Vatsal has asked about the links, but the links are shared above. If you look at the Dropbox folder, you should be able to get the links from there. That gives everything, including this presentation. Everything is in that Dropbox folder. I'll just share it one more time in case there's. Oh, have I shared with hosts and panelists? Sorry. Yeah. Okay. Now I see. I shared with the wrong group. So that's the Dropbox link where you can get all the code. And then that's the web page where you can actually see the stuff there as well. So it's just a little bit easier to download it from the Dropbox, but everything is available on the site. So great question, Vatsal. Thank you. Good. Then I know some of you are struggling downloading the data. That's always going to be a problem, I'm afraid. But I put in the chat, I put 3 links to the absolute essentials. So that's the code and the Spanish League, which is which you can download there. So the essentials are there in the chat above. I don't know about the JSON error that Kamal is getting. Francesca, there's a few questions about if the recording will be shared. I mean, from my point of view, it's absolutely fine to share the recording, but I wasn't sure technically if you could maybe say something about that, because a few people have been asking that, if you could share in the chat, Francesco, if the core.
Can you hear me?
Yes,
Yeah.
I can hear you.
We
Yes,
are,
yes.
we are recording the whole masterclass. We can maybe chop it up in pieces and then make it available the various sessions.
Yeah, that sounds amazing. I think that's really good. For me, it's brilliant if this can be shared afterwards so that people can go through this in their own time and pace. I think it's good to get, I like the idea of like, just because it's always easy to say you're going to do something, but if you're all in this room and this is your opportunity to do it, just get as far as you can with this exercise today, and then you can of course follow on in the future and so on. But let me show a few things about what those of you who have maybe got going are seeing. I'll show it first in my slides, then I will show it on the screen. So the first thing that we plot in the code is the number of shots, right? So this is I call it like a 2D histogram, where this is the total number of shots from different places. So you'll see that there's a lot of shots here, but there's also a lot of shots from outside the box. This line here is a bit strange, and I think it's a sort of error with the data, really, that normally the operator who collects the data will say that the shot came from outside the box or inside the box and won't put it on the line of the box. I'm not sure if players are reluctant to shoot precisely on the line of the box. So that's what that's caused from. And you see that there's lots of shots from everywhere. And then if you look at number of goals, you see that that's a very intensive heat map here in the box. And that's related to what we've seen with expected goals. Now, goals divided by shots is, of course, the frequency of scoring. So how often a particular shot is a goal. And really, that is what the expected goals model is. It's just trying to estimate from a particular place on the pitch or with a particular type of shots, what's the frequency of scoring. That is expected goals. And so if we divide the goals by the shots, we get a new histogram, and that's what we do in the code. And it shows us that there's a very intense red area in the type of circle that I showed you around the goal, or there's even more intense when you get close in. And this could in some ways be seen as an expected goals model, but you can see it's not really smooth and it's not so realistic. So here there's a few dots here where people have scored from out here, but these are exceptions. These are not very, it's not very likely to happen. So it's just that it happened to occur the few times they shot from out here. Maybe the goalkeeper was off his line. Maybe this was a cross that went into the goal, which was really meant to be a cross. That happens sometimes. So those ones get counted out here. So we have a kind of expected goals models already with this, but what we want to do is smooth it out and make it realistic with using a model. And so I've got you started with Python, and we're going to be building a model. We went through already the stages earlier in the talk. We went through the stages of building a model where we use the goal angle as the feature. And what you're going to do now is you're going to use the goal angle as a feature. So we've got these different goal angles. And in the code, I'll show you this in a minute, we plot. This isn't actually data points. It's important to point that this is also a histogram. So I've taken the average probability of scoring. So if scoring is either a 1 or a 0, 1 is a goal, 0 is not a goal. And then I've taken the average of those for different shot angles displayed in degrees. And you can see that this is an increasing curve. So the bigger the shot angle, the more you can see of the goal, the bigger the chance you have of scoring. And then the question for you, the mathematical question or the statistical question, is fitting a line to this data. And in the code, what I want to emphasize here in the code is that what we're really doing when we're doing logistic regression is fitting a line through this data in some way. And I'm going to come to how we do that statistically, how we do it properly statistically first. But what I want you to have a play around with just now is just trying that by what use this word random. It's not really random. It's your own coefficients. So putting your own coefficients in here and trying to adjust the values. So the coefficients are the parameters which determine this curve. You put those coefficients in and you try and get the curve as close to the correct thing as possible. I'm actually going to just change. I've put 1 second because that's wrong. We want to come back here at 11:15. I want to do. I think that's right. Yeah, because I want to have a break as well. So I want you to work for a bit and also have a break. So I'll show you first what we're going to do. Can you still see my screen? I think you should be able to. So here is now what I'm kind of, anyone who's maybe my age will have grown up using MATLAB a lot. And because you've used MATLAB a lot, I love this spider program, which probably isn't I know most people use some sort of Python notebook or something like that, but I'm kind of used to this spider, so I use it a lot. And here I've just copy and pasted the logistic regression. And so what I mean by random coefficients is I've just put these values 3 and -3 in here. And if I look up here, here's these values 3 and -3. And so I might think, well, can I adjust these values to make it better? So if I change that coefficient to 2, how do and I replot it? So I've changed the coefficient to 2. I replot it. Here was the original plot with 3. I changed the coefficient to 2, put it into here, and you see the fit has got worse. And so the job I would like you to do, what I'd like you to do before the break, and then you can have a break, is you can try different numbers in here. And when you've finished your guesswork, put in the values of B that best fit the data. So I think work with the Spain data that's already loaded in there and try and find the values of B that both fit the data. So 2 was worse. So I might try, for example, 4. Yeah, I have to change it up here. Make another change here to 4 and put that in there. And wow, that's got a lot better actually. So try to find the best values of these coefficients which matches the data. We're going to do this by hand first, and then we'll do it by logistic regression, which is the proper way of doing it. I'll try and help you a little bit with any downloading problems that you put in the thing. I'm not sure about some of the errors that are coming up, I'm afraid. But what we'll do now is I'll let you get on with this. I'll put this slide up there so you know what you're doing. So try adjusting the values of -3 and 3, see how you can do this. And can you use this by hand to get the best things? So get started, do some work, and then have a break. And we will return here at 11:15 to continue looking at this problem. So have a go at that, and I'll be back here at 11:15, 10:15 in Europe.
No, I mean, there is this discussion between soccer or football as a problem. Ah, yeah, but here the level is no soccer. Yeah. So we use soccer. I support the country. Where you think? I think it's, you know anything?
I've unmuted myself, so somebody had a question there. So if Martin, you had a question? Yes, Martin, you had a question. You've made her scared now of the Good. We'll get started in about 3 minutes again. But what I'll ask you to do, please, is everyone puts in their if everyone puts in their answers for their estimates into the chat. then we'll see what kind of estimates we have for the parameter values. Then we'll compare them when we do the fitting. So we started with b equals, what was it, 3 and minus 3. So that was where we started. So if you write some format of that type, b is equal to whatever you got. And we'll see what we got. So yeah, Cabella's quickest in there. He's got 3.5 and minus 2.7. Or 3.4 and minus 2.7. That's very good. Good. We'll I see that there's lots of answers coming in there. It's very nice that you've got going and worked with this. Really good work. And I think the answers, well, we can't get the exact right answer with this thing, but there's lots of answers there around about right. I've lost the chat just now. I was on the screen. Find the chat. I'm having some difficulty finding the chat, but there's lots of the close answers in the thing. I think it should be, what did you have, Kim? You had.
Yeah, 3.5 and minus 2.9.
Okay, so Kim here had 3.5 and minus 2.9, and that's around about the correct answer. So and we're going to show that, we're going to use logistic regression to show that. The reason I always do this with the actually trying it by hand to fit, this isn't a rigorous method, and in fact there's problems with this method because it overweights infrequent values because there's not an equal number in each of those boxes. So when I show these, when I show, for example, this, so these, the reason I couldn't see the chat was because it was up here on the screen. Okay, so is that back there? Okay, so the up here, so there's a lot more values. There's a lot more smaller shooting angles than there are larger shooting angles. So if you fit in this way to this curve, you're actually overweighting these very rare points compared to the other points. So it isn't a, mathematically speaking or statistically speaking, what we've done isn't a valid way of fitting it. But I think that many people forget that when we're doing machine learning methods, that's really what we're doing, is we're fitting curves to data, and we're doing it in the rigorous best way we can do it. There's many different ways to fit curves to data, but we're fitting the curves to data in the way that's prescribed by statistical analysis. And so it's important that we always remember that we have that. That's pretty much what we're doing whenever we're doing machine learning, is fitting curves to data. So you've now done this, and what we're now going to do is, well, we're going to actually build the model and we're going to fit it more rigorously. The method we use is logistic regression, where we fit the following model. So we have different names. When we teach statistical machine learning here in Uppsala, we call Y the output variable, and we call x1 up to xn the input variables or the features. And we want to predict the probability that y is equal to 1 or that y equals to 0 as a function of the feature variables. And the feature variables, in your case, there's just one of them. It's the goal angle, but there can be more than one of these feature variables. Sometimes, I'm afraid, in my notes, I go a little bit backwards and forwards if I have a minus sign here or not in this function, but that just flips the signs of these coefficients. And essentially what we're trying to do is estimate these coefficients. You've estimated the coefficients here to be minus 3.5 and 2.9, if we take this minus here. So that's what you get by hand, but we want to use a statistical machine, or we want to use a statistical method to fit those particular coefficients. And I want to illustrate, well, what is the proper way of doing this? Well, the proper way of doing it, we can't, as I've said, because we've got lots of points down here and we've got very few points up here, we can't use the method that we've actually adopted. Instead, we use maximum likelihood estimate. And how does the maximum likelihood estimate work? Well, it does the following. It looks to see, so here we've got the blue ones here are the shots that were not a goal, and the red ones here were the shots that were a goal. And in order to maximize the likelihood of this, we find the curve, the black curve here, that has the minimum distances between the 0, which is not a goal, and the probability that it's not a goal, and between the probability that it is a goal and here. So we minimize these distances in order to get the best fit of the particular model. So that's the method we use here. And we often calculate in terms of log likelihood, because when we multiply, we multiply all of these numbers together. So this will give us a number of it not being a goal. This is a number for it not being a goal. We multiply all of those together, and then we get the likelihood, but that tends to be a very, very, very small number. So instead we work with the logs, because then we just sum up the logs of every one of these values, and that gives us our log likelihood value. And to illustrate this clearly, what I've done is in the code, I have actually calculated log likelihood by hand. Well, by hand. I say by hand, I mean, I've got the computer to do it. But this is for the first points. If I take this over here and plot it here, I've calculated for, the Spain data is a bit different than the one I've shown, but there's been 3 goals. And so I find all the goals and I find what is the likelihood of this thing. And then I calculate the log likelihood of that. So if you go through this data step by step, you'll find how I'm adding up the log likelihood by taking the log of each of these shot probabilities, essentially these distances here. And I think it's very important to understand the basics of this method, like why we're doing this in the way we're doing. We want to find the best possible line through the data. How do we do that? Well, we minimize these distances between between the line and the data points. And here I've just done it for the first 40 points, is it? So we can do it for more and more points, and then we can find that. And of course, and you could add more and more points, but in practice, there are tools which allow us to do this fitting. And so in the next line, I actually do the fitting using one of the machine learning tools that we have, and it tells us that the correct value is, so you were a little bit out, Kim, in your guess. So 3.6 and minus 3.11 is the correct values for the two parameters given this way of fitting. Are there any questions about that? Any questions about that or anything else that you've encountered during the time? I'm just having a look through your questions now. There's a few people trying to sort out each other's Python things. Could you? Okay, good question there by Cabello asking, could you please explain the shot angle calculation in the code? Let me have a look at that. So that's further up. So that was what I think. I'm not going to do it in the code because it might be more confusing to do it in the code. What I'll do is I will do it. I'll go back to the slide where I made that calculation in order for you to see that again, because what we were interested in is we had this shot angle, and then it's basically trigonometry. And it's good you're asking me this because the homework for you guys is going to be based on this, but you've got the angle here, theta, and then I call this high school trigonometry. Not everybody in Sweden, for example, has done this as high school trigonometry these days. But basically, we take the sides of a triangle, and we have a question where we know three sides of a triangle, A, B, and C. B is the size of the goal, and we want to work out this angle theta. And then we use the sine laws and angles of a triangle in order to go through the calculation to come up with this equation. So the y in this case is the distance from the center of the goal, and the x is the x coordinate up and down the goal. And so it's trigonometry which gives us that equation. And if you go into the notes, you can go through in a little bit more detail how we come up with that. And then what's implemented in the Python notebook is that equation with the arctan theta with those things. The 7.32 is the size of the goal in that. It's 7.32 meters wide. But good question. Thank you for that, Cabela. Is the distance between the shots, non-goal, and the curve not maximized as the blue lines are a lot longer? Yes, I said, wait a minute, is it maximized or minimized now? Now you've got me unsure about this. Yeah, because it's the maximum likelihood, isn't it? Yes, sorry. I kept saying minimize. This is a very good point. I said minimized over and over again, but actually it's maximized. You're exactly right. Rowan's question is very good. I'll just say that again, because I got into, we always minimize when we do least squares, but it's maximum likelihood estimate. So let me just show that again. Oh, sorry, that's the wrong thing. Yes, and you do want to maximize because you want to maximize the probability. So it's a very good point. So you're actually maximizing the lengths of these lines because this black line is the probability. It's not a goal. So you want to maximize those lines. If I'd fit it to the dotted line, it would be minimized, but you're actually trying to maximize to the not a goal line? So very good question. Thank you for pointing that out. Good. There's a question here about why we're not considering the height of the goal poles. I think the height, I think we're always interested in the XY. We're interested in the shooting position. So the height of the goal poles don't really come into it. It's always the same for anywhere you go into. But there's some way I could see a model where you might want to put into the height. But there's a first approximation. The distance between the goal poles is enough to allow us to model this type of thing. Good. And then I think I'm not going to I'm very sorry. I got cut off I don't know why it cut me off the internet now. Now I don't know where I was talking for maybe 10 minutes or something before I realized that nobody was in the chat anymore. So let me just say what I was at the end, because I think the important thing for you, if you're doing this as a masterclass, is that you have a hand-in to do. And the hand-in is as follows. The challenge for you is to build a model with a feature as angle from the center line. So this is the parameter alpha, and this is a new parameter. So instead of the goal angle, we're going to use alpha. So you should first calculate alpha. So now you need to get your trigonometry notebooks out and work out alpha. And then once you've calculated alpha, you should use it as a feature in order to predict whether it's going to be a goal or not. You can also add other features in if you want to use distance or anything like that. That's fine as well. But you can use alpha as a feature in order to make those predictions. And when you've done that, send your answers to david.sumpter@it.uu.se. And I can also tell me if you've got a local teacher who's like examining the course that you're doing, you can ask that person, and I will send an email to them saying that you've passed the course when you've sent me that. So just send me that as a Python notebook. And so that's what you have as the exercise. So are there any questions about today's, I don't know exactly where I was cut out, but are there any questions about today's exercise and thinking about this as a challenge in the future? Before, what I'll do in the last 20 minutes is I'll talk a little bit about how some of these things are used in football clubs today. So any questions before that? Yeah, I'll repeat that. I'm happy to repeat the assignment. So the assignment is as follows. So the challenge is this. So the challenge is this. It's good that the last thing you remember was that I was calculating the shot's angle. So the challenge that you have is to calculate a different shot's angle. So you are asked to calculate a parameter alpha, which is, instead of being the angle between the posts, is the angle between the center line and where the shot was taken from. So you add that as a parameter. You can also have distance as a parameter. In fact, I think you'll need to add distance in order to work that out as well. So build a model where the feature is angle from the center line. Maybe I'll actually add that explicitly, because you need to add distance as with features of angle from the center line and distance. So build a model with the features angle from the center line and distance is the challenge for anybody who'd like to pass this part of the masterclass as part of the course, and submit your answers to david.sumpter@it.uu.se. I think we maybe can find some other way of making sure that this problem is shared with you afterwards. Email address, Matthias asked for email address is there. Maybe I'll just type it into the chat too. So the problem is build a model. The slides are in the Dropbox I shared at the start of the talk, but we'll make sure we share them as well. My email address is for submitting the work is that. So please feel free to submit the work there. Good. Any more questions about that? I'll also, what I'll do is we will share the slides afterwards, but let me just share the slides in the chat for anyone who'd like to download them just now. Yeah, good question. Benjamin asks if there's any specific data set you should fit the model to. No, I think if you want to do it the best possible job, you should load in all 5 of the leagues and fit it to all 5 of the leagues. And yeah, Kamel asks, are you flexible to use any regression model? I think that you can use any regression model you want, but I also would like somehow for it to help explain the importance of the different variables in it. That's why I like logistic regression. A question about the angle alpha. I'll explain that one more time then to try and get that across. So if I share screen, desktop 2. So here is alpha. We draw a line, a center line here. Here is alpha. Here, so if the shot is there, then alpha, I don't know what's this, it's about 30 degrees, something like that. If the shot is from the middle, alpha will be 0. If the shot is way out here, it will be 90 degrees. So you should be able to see already now that the bigger alpha is, the less chance you have of scoring. So you want to model it with both the center line and with the distance. Yeah, I mean, right, that's a good point. So where's the shot taken from? Yes, the shot is taken from this point here. This is the point that the shot is taken from. Yeah, very good question. Okay. Due date for the assignment, let's say 3 weeks time. So I'm just making that up, but send them to me in 3 weeks time. But I'm happy to look at these in an ongoing thing. I'll just basically check through the code and tell whoever is locally examining you that this was okay, and so on. So whenever you're ready with that. Let me just share the slides here, because it's good to have as many ways of sharing these things as possible. So this is the practical part of the course. Then the other part of the course, the first part of the lecture I gave is down there. So you can download those things directly. They're also in the folder that I shared at the start of the masterclass. Great. What I want to do for the last 15 minutes then is give you some idea of how a few of these things are used in practice. And what I'll do is I'm going to share. Yeah, I'm going to share this. So how do we okay. You guys can't see it locally here, but maybe I'll put this up here. Okay, so how do we use this in practice? As I said right at the start of this course, there's been a lot of interest in using this for professional football clubs. And this is a talk I gave to professional football clubs about how they can use data. And I went through the same story as I went through with you about how I work together with teams. But clubs are now like finding themselves in different steps. They're starting up with data. Then they use what we call bespoke metrics, and then they start to use AI methods, and they can scout off the ball. We've talked a lot about on the ball data, so passes and shots and so on. We also want to look at movement off the ball. And from there, you can build up a data-driven playbook, and you can make data central to everything you do. So what do I mean by this? Well, let's just start with some of the ways in which clubs are starting to use data. And some of it is quite basic. This is where we worked together with a Premier League club, and we wanted to make a full match report for them directly after the match. And these are some of the things we might show them. So this is an expected goal shot map. So the size of each of these circles is the expected goal value. So the bigger the diameter of the circle, the bigger the chance. And the star is a goal. And so that gives a kind of on the pitch view of the chances created by the two teams. You can also look at these things through time. So the height of these is the probability of it being a goal, so the expected goal value. Very big chance there for Cologne, which they scored at the end. And then there's other things, is we can use expected threat. So this is an example of how we might use expected threat. This is expected threat difference for the two teams. And you can see Cologne dominated here for a bit, then Bayern dominated, and Cologne dominated again, and it goes backwards and forwards. We can also, using a Poisson model, once we've worked out the expected goals, we can work out the win probability for the different games. This was the last game of the Bundesliga. Bayern needed to win this match to win the Bundesliga. If you look on the chances that they had, they actually shouldn't have won this particular match. We do a lot of this. So what's shown here is different statistics for the match. So this is a non-penalty expected goals in the game, expected goals per shot, shots that the team had. And what we compare it to, the white dot is the current match, the match against Cologne, and all the other red dots are previous matches. So we can value, and this is often what clubs want to do, they want to evaluate their performance in the most recent match they played against all the previous matches they've played in the season. And that's what we're attempting to do in this plot. We can also look at things like entries into the final third. So this is what's plotted here is these are the passes which took the ball into the final third. And then we look from there, what's the probability, what was the expected goals that was generated after that? So there was only one ball into this area of the pitch, but it generated an expected goal value of 0.38. So it's not that this ball has that value, it's that this particular pass into the final third then led on later in the possession chain to a 0.38% shot. So this allows us to see like where teams are dangerous. So if you do this over a number of matches, you can find out both where a team is dangerous, and if you do it for their opposition, you can find out where a team is weak, if there's one particular side of a team that you should attack more often than the other. And Cologne had quite a lot of balls into the final third, but they didn't produce many expected goals from those particular things. So that's a way of preparing for opposition and also analyzing your own strengths and weaknesses. Then we can look at things like passing networks. This is also available on the web page. And this is where we start to take graph theory into football analytics. What's plotted here is the passes between the different players. The thickness of the line is how often they passed each other. The defenders pass each other quite a lot. The color of the line shows how much expected threat they generated. So if you go back to the start of today, we were talking about expected threat. Darker lines means more expected threat. And we can also rank the players in terms of their expected threat contributions. We can also do this. So this is a match report, but you can also do this over the season and find out where the players were playing and who contributed the most over a particular season. I'm going to share this so you can have a look at, I'm going to share this talk as well, so you can have a look at it afterwards, and you can download the types of season and match reports we make from this data. Then what we tend to do is then we start to look at what we call bespoke metrics. And this is one of those examples. It's a case study, and it's when we win back the ball, we want to create chances. And we create something called a KPI, which I didn't know what a KPI was before I started working in the football industry, but it's a key performance index. And so the key performance index is the expected goals created with each ball recovery. And here's Barcelona women's team. And the size of the circle here is the expected goals created after they won the ball back. So when they won the ball back here, they created a very good chance through winning the ball back here. The star means that they scored a goal as usual. And the small dots mean that they won the ball back, but they didn't create a very good chance for that particular opportunity. So you can begin to assess whether you've got this performance question, you've got a measurement that you want to make, and you can look over a number of matches. Are we managing to succeed in that particular challenge? Here's another example. So Jude Bellingham, many of you will know about this amazing player, very difficult player to stop. How do you stop the best player in a team? Well, here is an idea about how you might stop Jude Bellingham. Instead of trying to stop Jude Bellingham, stop the players who are passing the ball to Jude Bellingham. And this is him in the Bundesliga. These players are the three most often suppliers of the ball to Bellingham and their average position where they make the pass. And so we identify who is making the expected threat passes to Bellingham, and then we try to say, let's stop that player instead of concentrating on Bellingham, who's very, very difficult to stop. So that's one way of doing it. That's a case study that we've done. We also, another type of case study, this is using tracking data and following the players. We can look at the runs that a player makes during a good attempt. So now we're using data where we can follow the player off the ball, and we're looking at Nketiah's runs, off the ball runs, whenever we have created a good opportunity. So it's the expected goal created for the whole team when a player sprints. So again, using expected goals, but also putting some context around it with the runs that we use. So that's a lot of how we've worked. I have a company 12 who does this, and what happens is clubs come to us with different questions. This is some of the questions that they've asked us, and we try to use data and metrics to answer those questions and get a better understanding of how, well, basically we always create a KPI. We always create a KPI, and then we also always create a visual which explains the KPI. That's our basic way of working with these different questions. How we work actually is quite interesting because we work very closely. We mainly employ data scientists. So these are 4 of our data scientists who work for us: Janne, August, Nicole, and Pega. Nicole is quite amazing because she's also a professional football player. She plays for the Ukrainian national team and has played in Denmark, Canada, and she's currently playing in Ukraine. And she also works part-time for us as a data scientist. So what we try to do is we work very closely with the data scientists, having contacts with the team and answering their questions using data, which I find a really fun way to work, actually working on real life problems. We've recently done something, and I saw some people talking about ChatGPT for various things. We've recently done something where we've created a scouting bot, which we call 12GPT Scout, which can write reports. So we haven't, we've trained it up on football data, and then it can write short reports about the player. This is a report we did for Bunny Shaw, who plays for Manchester City women's team. We feed it in this data and it writes short reports. We can even talk to it about players. You go into the app, you select the player that you're interested in. First, it gives a summary of that player. And then once it's given a summary, you can have a little chat with it and try and work out why it's drawing the conclusions that it's doing. So there's definitely a lot of excitement around using these types of AI methods for assessing players. But the basic starting point is always the statistics, and then we use that in order to build up the words and the understanding. We also compare players between leagues. This is a problem that comes up a lot for football clubs. And then finally, I want to talk a little bit, we haven't really got into this today, but if you look at the webpage, there's lots about this. Off-ball scouting, we use a method called pitch control. And what we can do is we can say, well, how much space did Marcus Rashford open up with this run that he made? And the red area evaluates the quality of the space that Rashford has opened up. And we can, if you look at this pass, you see that he slows down a little bit to receive the pass. So we can give Marcus Rashford credit for opening up a very dangerous space here, even if the pass isn't the optimal pass to him. So we can evaluate players off-ball runs in this way. We can even evaluate players off-ball runs when they don't get the ball. So this is an example where if you watch here, Luke Shaw's, oh, I've put the thing over Luke Shaw's doing a run on the left here. So watch it again. There's a player doing a run down the left here, Luke Shaw following down round there. And what his run does, he doesn't get the ball himself, but it makes it difficult for the defenders because they have to cover his run, and then it allows the pass to go in for someone else and a chance to be created. So those are the sorts of things that we can evaluate. Lots of exciting things to do with this. We can also look at high-speed runs. We can also develop tactics and so on. And I think I've hopefully convinced you by now that this football analytics isn't just very interesting mathematics and interesting data science, but it's also something that is increasingly useful for clubs. And that is what I have for you today. It's been really fun to talk to you. I see there's a few questions in there, so I will I'll answer those questions. Or do you want to round up, Francesco? Or will I answer some questions?
If you want to answer the questions, please, you're most and welcome.
Okay.
There's somebody interested in becoming your PhD or master student, but anonymous, so I'm not sure. Maybe you want to that?
Yeah, that's certainly possible. You should write me an email as well if you want to do that. It's certainly master's things. I have like a few master students sitting here just now. I've become extremely popular in Uppsala for master's projects recently since I started doing this. When I worked on animals, nobody seemed particularly interested. So, but now there's a lot of people who are interested in what I'm doing for master's projects. And then there's PhD positions. It is tough to find a PhD position in this area because you have to compete with the other, maybe more serious scientific areas in doing that. But now and again, there's PhD position openings as well.
Thank you. And then I think there are a few questions in the chat, David. I don't know if you want to quickly browse through the last ones.
Yeah, the last, so there's one question there about can I get access to the course in Soccermatics? Yes, the Soccermatics course is totally open. You just go into Soccermatics RTD.io, and then you have all the materials for it. Now, then the question is, the question is if you want to do it in a participatory way to go through the whole course. That we haven't, you have to be able to register as a student in Uppsala. And so you have to be a European citizen, I'm afraid, to register for the course to do the hand-ins. But maybe we're sitting here now, maybe this is something we can think about, Francesco, because the course runs in September. So we've got half a year to there. So we can certainly think about some way we could have another way of registering the course. So we'll definitely have a think about that because it is an online course. But until then, all the material is available at the website I've done. Great question there about the physical data like speed, number of sprints. That was shown a little bit in the example I gave of Enquete. If I think I can just go back through that. You can see that on the screen. You can see that on the screen behind me. I won't share the screen again. Well, maybe I do need to share the screen again. Wait a second. Yeah, so you can see that with Enquete runs. Here you can actually see his maximum speed, 33.2 kilometers per hour, average speed 19.9. These were all the sprints he did in connection with a good shot on goal. So when there was an expected goal attempt. So you can measure those types of sprints. They have cameras in the ground, or they can do it from broadcast data, where you can use it from the television data in order to measure those types of things. So that's how we measure sprints. There's one question here about fantasy football. In theory, they can be used to predict fantasy football and things like that. And I haven't really gone into betting so much or anything like that in today's lecture, but I have covered that in other things. My first advice for betting is, if you're not an expert mathematical modeler, just don't do it. There's no point. You're going to lose money because there's a small number of very good mathematical modelers who are winning all the money. But with fantasy, that's more fun. Certainly is. There's some projects I've seen online where people use this to predict fantasy teams. But unfortunately, my fantasy team is bottom of my friend's league. So I don't think I can give any good advice on fantasy football, I'm afraid. Maybe because I'm too busy with real football, but my fantasy team isn't doing very well at all. But certainly you can do that. Yeah, it was a question about is there a data science football community? I think the best place to start there is Twitter. If you follow me on Twitter, I'm on Twitter at Soccermatics, then you'll find other people who are involved in that community, and you can find and have a look at that. There's questions about the job market. Unfortunately, I always find this a little bit tough because it's certainly not easy, and I don't know precisely. Yeah, somebody said X. You know, it's X, not Twitter. But yeah, I'm at Soccermatics on X. Yeah. Yeah, the job opportunity market. Jobs do come out now and again. I'm not really on top of where you best find those jobs, to be honest. But some of the people on the Twitter community share around that. Certainly on LinkedIn as well. There's if you follow me on LinkedIn, I always accept friend requests on LinkedIn. So I'm just David Sumpter there. There's also people around there who share a lot of things to do with possibilities in the job market. I'm afraid I can't really say so much about it. Good.
Yeah, maybe this is then the point to thank you, David.
Yeah.
Because I think we reached the time limit. Thank you very much. It was really an exciting start to the masterclass series.